Hi everyone, in this video I will talk about the polycyclic aromatic hydrocarbons in marine food. So let's get started. So in this video we will cover about the following contents. Polycyclic aromatic hydrocarbons or PAHs are widely distributed and are located in the environment as a result of the incomplete combustions of organic matter. So incomplete combustions of organic matter occurs when the amount of the organic compound being burned exceeds oxygen levels required to cleanly burn the fuel. Next, many PAHs and their epoxide are highly toxic, mutagenic, and carcinogenic to microorganisms as well as humans, which this will give the serious health effect to the organism. The highest concentration of atmospheric PAHs can be found in urban environments due to increasing vehicular traffic and low dispersion of the atmospheric pollutants. So beside the emission from vehicle, burning coals and emission from the industry also one of the source of PAHs in the environment. Next, PAHs are hydrocarbons, which is organic compounds that contain only carbon and hydrogen only. It is composed of multiple aromatic rings, which organic rings where the electrons are delocalized. It is a class of carcinogenic organic molecules. It consists of 3 or more benzene rings, and it commonly produced by fossil fuel combustions. Besides that, pure PAHs usually exist as colorless, white or pale yellow-green solid. Besides polycyclic aromatic hydrocarbons, it is also known as polycyclic organic matter, polynuclear hydrocarbons, polynuclear aromatics, and polynuclear aromatic hydrocarbons. Next, this is the example of 16 PAHs and their chemical structure from the simplest one, naphthalene. From this, we can see all the structure were in benzene ring in which electrons are delocalized. This chemical structure of the 16 representative polycyclic aromatic hydrocarbons was decided upon by the United States Environmental Protection Agency US EPA. Okay, next, let's move to the physical and chemical properties of PAHs. The first one, it is a lipophilic and non-polar molecules. PAHs are highly lipid soluble, which lead to a fast absorption by the gastrointestinal tract of marine mammals. They are immediately distributed in a vast variety of tissues with a notable tendency for localization in body fat. The second one, they tend to persist in the environment because PAHs are not very soluble in water. They are weakly volatile and dissolve quickly in water. This because solubility of PAHs in water is inversely proportional to the number of rings it contains. So, if the number of rings it contains is high, then the solubility of it will decrease. Next, PAHs is soluble in many organic solvents. All PAHs are solid at room temperature and have high melting and boiling points. The movement of PAHs in the environment depends on properties such as how easily they dissolve in water and how easily they evaporate in the air. They can be deposited either by direct impact of particles and gaseous molecules on surface for dry depositions or by precipitations, wet precipitation. The molecular weight of PAHs range from 138 until 300 grams. This can be divided into two, which is low molecular weight PAHs and high molecular weight PAHs. So, for this group, it has its own properties. For low molecular weight PAHs, it is more soluble, more volatile, less hydrophobic, and those with high vapor pressure are predominant in gaseous phase. While for high molecular weight PAHs, they do not volatilize because they have high melting point, and they found mainly absorbed on particulate matter. So this table represents the summary properties of PAHs. From the table, we can see the difference between the PAHs with less than 3 benzene ring compared with the PAHs with more than 4 benzene ring. PAHs are also important components of crude oil and can contaminate the marine environment. Once in the aquatic environment, PAHs can be metabolized by vertebrates but not by bivalves, and this substance accumulate in bivalve tissues. PAHs are found in substantial quantities in some foods depending on the mode of cooking, preservation, and storage. Although for most people, fish and seafood represent only a small part of the total diet, the contributions of this food group to the daily intake of PAHs in some individuals is comparatively important. Marine species are widely used as bioindicators for environmental pollution because contaminants from seawater and their diet can be concentrated in their tissues, thus enabling the assessment of bioaccumulation, bioconcentrations, and biomagnification through the food chain. For the marine life that can be exposed with the PAHs contamination can be divided into two groups, which is vertebrate and invertebrate. This picture represents how PAHs can cause toxicity in marine foods. So oil spills contain several kinds of PAHs. Worldwide, polluted area exists even in the absence of oil tanker accident. So actually, low molecular weight compounds such as naphthalene and trirene PAHs are accumulated in both fish and invertebrates. So the PAHs derived from the aquatic environment are accumulated and are toxic to fish and invertebrates. Additionally, we describe the toxicity of OH-PAHs, metabolites of PAHs. The toxicity of OH-PAHs is stronger than PAHs, at least in fish. Figure 1 shows the concentrations of PAHs through consumptions of edible marine species from the research in Catalonia, Spain. From the figures, naphthalene accounted for the highest percentage, which is 21% of total PAHs. Dibenzoyl AH anthracene had the lowest percentage, with 1% only. So PAH mixture with a high percentage of low molecular weight compounds, which is 2 or 3 rings, have been reported in aquatic environments polluted with petroleum. Figures 2 shows the contributions of various fish and seafood species to the intake of carcinogenic PAHs by an average male adult, which 70 kg body weight in Catalonia. So from the figures, we can see that shrimp, hake and tuna were the main contributors, and swordfish and red mullet were the least significant contributors, both at approximately 0%. So in conclusion, marine pollution, particularly oil pollution, is a major threat to human and environmental health. Commercial species being suitable for consumption of marine environment such as fish, mollusks, invertebrates are demanded by consumers all around the world. Polycyclic aromatic hydrocarbons, or PAHs, are one of the most widespread organic environmental pollutants that pose a potential risk to human health via marine biota. That's all from me. Thank you.